Hello, I am the group leader for Section 1, Group 6. Today, we are going to present about the optimization of air conditioning in campus classrooms, which follows the theme Energy Saving using Six Sigma. The following are the members of our group. Firstly, my name is Tao. My metric number is MA25125. Then we have Lika Heng, matrix number MA25021. Sharifah Anu Shahada binti Sheikh Muhammad Zaki, MA25019. Adila Shahia binti Khairul Kanizam, MA25153. And Akmal Hakimi bin Ahmad Tris, MA25011.
Hi, my name is Lee Heng. My metric number is MA25021, and I'll be presenting about the introduction of our project. So, climate change is one of the most serious challenges facing the world today, and energy consumptions plays a major role in contributing to greenhouse gas emissions. To address this issue, the United Nations established Sustainable Development Goal 7, which is SDG 7. It aimed to ensure the access to clean, affordable, and reliable energy for everyone. As you know, universities consume a large amount of electricity, particularly through the air conditioning system that are essential for maintaining a comfortable learning environment in Malaysia. However, inefficient use of air conditioning can lead to significant energy waste and increase the cost of electricity. Therefore, improving the efficiency of air conditioning systems on campus can help reduce the energy consumption, support the environmental sustainability, and contribute to the achievement of SDG 7.
Let me talk about the project charter. There are 6 criteria to the project charter, which is problem statement, business case, goal statement, timeline, scope, and team members. Firstly, problem statement. The problem statement is lecture rooms frequently overclock to 19 degrees Celsius despite a 24 degrees Celsius mandate, causing a 25% energy waste, which is approximately 150 kilowatt hours weekly per room. Next, the business case. Resolving this inefficiency reduces faculty utility overhead and aligns campus operations with SDG 7, which is affordable and clean energy. The project's goal statement is to reduce weekly AC energy consumption by 15% while maintaining a stable ambient temperature of 24 degrees Celsius with a tolerance zone of 1 degree Celsius. The timeline of this project includes the defined phase, which is from week 1 to week 2, the measure phase, which is from week 3 to week 5, the analyze phase, which is from week 6 to week 7, and the improve phase from week 8 to week 10, and finally, the control phase from week 11 to week 12. The in-scope of this project is the split unique AC efficiency and thermostat behaviors in specific engineering labs. The out-of-scope of this project is central chillers, admin offices, and structural renovations. The team members in this project include the project lead, data analysis, process observer, technical liaison, and sustainability analyst.
I will present the major phase of our Six Sigma project. The purpose of this phase is to understand the current condition of the air conditioning system and find the main cause of energy waste. First, we collected the data from the selected lecture room. We found that the target room temperature is 24 degrees Celsius, but the actual average temperature is only 90 degrees Celsius. This means the room are about 5 degrees colder than required. Because of this overcooling, the air conditioning system used more electricity than necessary. We estimate the energy use is about 25% higher than the normal. Next, we use a SIPOC analysis to understand the process. The facility and maintenance team support the system. The main input are electricity, air conditioner, and room occupancy. The output is cool classroom for student and lecturer. After that, we identify the most important factor affecting the system. These are called Key Process Input Variable or KPIV. The four main factors are compressor operating time, thermostat setting, filter cleaner, and use behavior. We also carry out an FMEA analysis to find the higher risk in the process. The results show that continuous compressor operating has a higher risk score of 320. This means it is a bigger contributor to energy waste and overcooling. Looking at the current process flow, the air conditioner continue running even after the room become cool enough. As a result, the room temperature drop too low and more energy is wasted. In conclusion, the major phase confirmed that overcooling is happening in the lecture room. The main issue is the compressor running for too long. This problem will be studied further in the analysis phase. In conclusion, the major phase confirmed that overcooling is happening in the lecture room. The main issue is the compressor running for too long. This problem will be studied further in the analysis phase.
Hello, my name is Adila Shaira binti Karkanizam, MA 25153. I will explain on project impact evaluation on society. So, in the current problem is that the average classroom temperature is only 19.4 degrees Celsius, which is significantly lower than the recommended, which is 24 degree. This creates an overcooled environment and can make the student discomfort and cause stress. As you can see, the KPI used to evaluate the issue in classroom temperature. Our current measurement show that average is 19.4 degrees Celsius, while resulting in temperature gap 4.6 degrees Celsius from the target. The benefit of optimizations that I can say for society is by optimizing the air condition system and maintain the recommended 24 degree, student can experience better comfort, improve focus during lecture, and healthy learning environment. In addition, an healthy learning environment can promote awareness of responsible energy usage among the student and university community. From the economic perspective, the current problem results in excessive energy consumption. Based on our finding, the air conditioning system consumes approximately 25% more energy than necessary because the room temperature is maintained around 90 degree instead of 24. The KPI measurement includes excess energy consumption, temperature difference, compression efficiency, and operating costs. In excessive energy consumption, it was 25% higher than it should, and the temperature difference is at least 4 to 5 degrees Celsius below the target. For the compressor efficiency, it has a poor efficiency because it continuously working. For the operating cost, it will be higher. This saving can through optimizing, the university can reduce electricity consumption, lower utility bills, and decrease maintenance costs by excessive compressor operations. This saving can then be redirected to the other academic facilities and student development program. Overall, optimizing classroom air conditioning not only improve student comfort and learning environment, but also reduce energy waste and operational costs, creating both solutions and benefit while supporting sustainable development goal 7.
Alright, hello everyone. So today I'm going to explain project impact evaluation legal framework. So first we are going to start with compliance. So based on our measurements that the average classroom in EMP was 90.4 degrees Celsius, while the government recommended temperature was 24 degrees Celsius. This indicates that the current classroom air conditioning settings are not fully compliant with the recommended energy saving guideline. By adjusting the temperature to 24, the university can improve compliance and promote more efficient energy usage across campus. Next, regulations. The government encouraged public institutions and educational facilities to adopt energy efficient practices to reduce unnecessary electricity consumption. Since air conditioning system are many Since air conditioning system are major energy users, maintaining the recommended temperature of 24 helps support these energy conservation regulations. Implementing the recommended set the demonstrate the university commitment to responsible energy management. Next, standards. The recommended temperature of 24 degrees Celsius serve as a standard that balances occupant comfort and energy efficiency. Our finding shows that average classroom temperature is significantly below this standard. Therefore, optimizing the air conditioning settings will help ensure consistent temperature control, maintain thermal comfort for students and lecturers, and improve overall facility management. Alright, next, project impact evaluation environment. We are going to start with the pollution. The current average temperature of 90.4 degrees Celsius requires the air conditioning system to consume more electricity. Increased electricity consumption leads to a higher carbon emission from power generation. By adjusting the temperature to 24 degrees Celsius, energy usage can be reduced, which help lower pollution and greenhouse gas emissions. Next, biodiversity. Although the project does not directly affect wildlife, reducing electricity consumption helps decrease environmental pressure on natural resources. Lower carbon emissions contribute to reducing climate change impacts, which can help protect ecosystems and biodiversity in the long term. And lastly, ecological health. Optimizing classroom air conditioning temperatures contributes to better ecological health by reducing the industry's environmental footprint. More efficient energy use supports sustainability goals (SDG), promotes responsible resource management, and helps to create a greener campus environment. So, in conclusion, optimizing classroom temperatures from 90.4 degrees Celsius to a recommended 24 degrees Celsius improve compliance with guidelines and standard while also reducing pollution, supporting biodiversity conservation, and promoting ecological sustainability. That's all from me. Thank you.
In conclusion, this project identified energy waste caused by inefficient use of air conditioning in university classrooms. The finding shows that AC units are often left running in empty rooms and set at unnecessarily low temperatures, leading to waste electricity and discomfort for students. Improving the AC usage can reduce the energy consumption, low costs, and support the Sustainable Development Goal 7, which is SDG 7. By promoting clean and affordable energy, although challenges were faced during data collection, the project provide a foundation for future solutions such as smart sensors and awareness campaign to create a more sustainable energy efficient campus. Thank you.